why am I designing for technology? Why am I making technology? How am I going to use the technology to change people's experiences so that I can change the world?
I think if you go into the late 80s, early 90s, there was a growing awareness that design had a need to take a greater responsibility for understanding how what it produced had effects both environmentally, economically, politically, in just the lives of people. And then, so that demand for responsibility then gets kind of hit with emerging new technologies and network communication. So suddenly that awareness of people's lives and the technology to disseminate information and ideas suddenly, I think, changed the role of design.
I saw this O'Reilly publication called the Whole Internet Catalog, which came out in like 91, or maybe 1990. But rather than the Whole Earth Catalog, which kind of listed kind of solutions, like here's a specific tool you can buy, here's the Whole Internet Catalog was essentially about kind of emergent, you could say protocols, but emergent services that were happening on the internet. And one of those, in the very first edition of the Whole Internet Catalog, was this thing called the World Wide Web. And I was a Unix system administrator, so I was like, it's easy for me to spin up a website. Turned out there's probably like one of the first like 100 websites, but I learned about it through the O'Reilly book. And that then got me thinking, this is actually different than all those other things. This actually has a quality to it which feels like it is much more accessible. It is much more of a read-write medium where you're not just like downloading a text file, but you're actually changing the experience that someone has. And you can do it in a very, very easy way.
Yeah, I think the internet at the beginning was, from my perspective, always for creative work. It was before the dot-coms got started, and especially before like before things became standardized. So like every time you built a site, you were building something from scratch, and you were exploring and testing things. There were no standards about how to navigate from A to B, and so people were really, I think, building radical ideas. And then over time, a bunch of conventions were made that the menu needs to be on the left, and these are how a pull down kind of operates for navigating through a site. But I mean, that was more for the web as publishing. But I think there were people exploring it in other more personal ways, through writing projects, through ways of collecting photography and navigating through photography in different ways than a book. Just kind of messing with what's there, like making the most of the blink tag and form buttons to produce things that are more like landscapes and are non-functional. So I think that was my first experience before it moved into more a tool for corporations to expand their business or expand their presence. It was like individuals doing things and sharing things. Like I think maybe some other people have talked about the view source button through the menu. That's how we all learned at the time. Of course, there were no classes on how to do this at the time, so you would kind of go to the bookstore and get a book that's about this thick of like, this is how you can use fetch and transfer files, and this is what a B tag is and all that kind of thing. And people would they'd learn and read and then look at other people's source. You found something interesting, you would dig in and learn how to do it.
The single most interesting aspect of the early web was just the two words view source. The ethos, the capability, the possibilities of view source in the early web meant that anything that you could see how it was built, and you could change it and build it and put it back out. That is a magic that has been lost. And it was so important. It was so, so important. And the loss of that is, I think, what makes the disconnected ethics and sensibilities of Silicon Valley possible. There was this early moment where everything was basically comprehensible, and that was the single most beautiful thing about the medium, because that definitely wasn't true about painting. It's not true about photography. You know, it was like all of a sudden there was like this mode of expression where anything you could see could be decompiled, and you could like get into the roots of it, and that's magic. You know, you go into a museum, and the fact that you can't view source is part of what provides the mystique of the whole thing, right? But there was a moment, let's say 93 to, I don't know, 2000 or so, where it was comprehensible, and to me that was the most beautiful moment of the medium, and it's long gone. I think it is many things now, but I wouldn't call it beautiful.
I think the big changes in kind of the mid-90s, and I'm talking about like 95 through like 98, was that there was still this significant Bay Area countercultural utopian component to the vision that people had for technology. The technology wasn't just going to make people money. Technology was going to unify people. Technology was going to give people who didn't have a voice. Technology was going to distribute information to people who needed it from people who had it in very, very inexpensive ways that would then enable the entire world to be better as a whole. And so all of that was enabled by a core set of these technologies, and it was very idealistic. And we started kind of like thinking about, well, what does this mean commercially? What does this mean not just in terms of like sharing physics information, but sharing all information? Hotwire essentially invented the ad banner. And the ad banner was just this really interesting thing to come out of that, because it was an acknowledgement that the utopianism had to be paid for. Broadly speaking, what happened was a bubble in the valuation of companies that were on the internet. So there were some initial successes in the mid-90s. So starting with kind of e-commerce. You started getting Amazon, which launches in 94, I believe, like the end of 94. You get eBay. You get Yahoo, which launches in like 96, 95, something like that. And you're starting to see that a lot of people get a lot of value from this technology. There's potentially a lot of money in this. In like 97, 98, 99, you start to see this increasingly like astronomical valuations of companies, where Yahoo becomes worth as much as General Motors over the course of a year. And Yahoo makes no money. And Yahoo doesn't know how to make money. And, or you see companies that are like, we solved this tiny technical problem of synchronizing video. That's not even YouTube, that's broadcast.com, I think, which is how Mark Cuban made all his money, is that, and people are like, oh, that's gonna be huge, it's gonna replace television tomorrow. So that means that you add up all the value of all the television networks, and then that's what they're gonna be worth. That's what broadcast.com is gonna be worth. So we're going to run their valuation up to that. So obviously, you know, there's a hangover from that. And the hangover that happened in 2000 was that you can see some of this in these very interesting things where like the advertising in internet magazines at that point becomes like, especially like 2000, becomes crazy. And of course the Y2K bug drew a lot of attention to this new technology, this new internet technology, this new computer technology. So the confluence of that in 99 and 2000 brings a huge amount of attention, a huge amount of money. You see these magazines that were really kind of like for very niche audiences grow to be like this thick, because it's like, you know, 400 pages of ads for various internet things. And then the crash happens. The crash happens in, someone can probably look up the exact point. I mean, it wasn't exactly like the 1929 crash, but it was very close. So essentially, the bubble bursts, and you have valuations start crashing down.
I'd say, treatment of the internet, the guy who sits in that chair right over there, Clay Shirky, coined around somewhere in there the term social software, which became social media. And it wasn't new. I mean, the internet is a social medium, but it was making the case that it would be used for that. It's not just going to be a brochure for big, large entities to manifest themselves. It's going to be more of a conversational place. And so it wasn't a technological shift. It was a perspective shift. Was something major.
That wave, what was interesting was coming right at the end of the dot-com bubble. It was a shift from seeing the web as a consumer media to being a participatory media. And I think that's a big part of all the things we're talking about, is this notion of participation. We skipped over the wave of CD-ROM, but that's okay. They could be buried anyway.
A new technology will change the design field. And I think computers are one of those technologies that has changed design. Just Bauhaus brought modern materials in, that the interaction design people bring computers into the physical stuff we create that have sensors and processors and actuators.
I think I was trained as a product designer fairly crudely, and it was mostly just about making objects manufacturable and appealing. And it was quite a lot of years later, when I started playing with computers, that I started getting really interested. And the reason why I went to start playing with computers is how do products actually communicate what they do? If you make a fork act like a fork, it looks like a fork and reminds you of what the purpose of a fork is. The problem is with a computer that you don't start with a mechanical description of the system. So there's completely a point in making a laptop efficient and making it the batteries fit in the right place, but the system inside a laptop, what you're actually trying to do, the product is on screen. The product is purely on that surface, and it doesn't have to be purely on that surface. And that's where I get curious, is how does the physical world and the graphical world come together to describe new products? In theory, graphic designers should be the people taking over product design. Once products become pieces of communication, then people who study and have trained in how to communicate ideas through paper or through print should be the people who know how to organise an object to communicate well. The catch here, and the thing I'm fascinated by, is why haven't graphic designers taken over? And I think part of the problem is that graphics is so often to do with, well, one thing to do with print, the other thing is to do with messaging, not making active things. So a product it communicates because you act on it. It doesn't just tell you something, it's a system that you come back and you use. So it's trying to tell you how to use a system, the product is, whereas graphics often is just communicating an idea.
Lots of students move straight into software when they're generating ideas. So actually giving them the skills where they can draw and think within, with a piece of paper and a pencil is, I think, still a really powerful tool. And you'll always see if somebody's got a sketchbook packed full of brilliant drawings and ideas, it always convinces people. People find it like alluring and interesting to look through somebody else's kind of ideas. I see drawing in a really expanded way, and I think some people can get familiar and adept enough at some softwares where they can actually sketch and draw and think through things in software. I think it's hard, and I think you've got to do it for a really long time and be really good to be able to have that level of fluidity. But people can do it with objects, like, creating, sketch models. So I think it's, there is a physicality between like your hand and your eye and your brain. As you as you're drawing and you see something emerge in front of you, I think your brain's, it's like that idea of externalizing this abstract that's in your head, and when it's there presented in front of you, you reabsorb it, and that changes how you think about it.
Our emphasis on drawing and the embodiment of still hand drawing at large scale for hours and hours on end is something that puts the knowledge of seeing and perceiving into your body. And we don't look at drawing as just representation. Drawing is a form of thinking. It's sort of connecting and developing ideas, but it's also understanding how to perceive and experience things and sort of embed them in your sort of in your haptical senses.
You need to be able to make things, because an idea is not enough. You need to feel what it's like when you interact with it.
At Berg, we had quite a lot of language around thinking through making. And that's a popular idea now because it's incredibly helpful for creating belief. And I've always felt like that's mostly what prototyping is, at Berg at any rate. It was a kind of creating things that got enough sort of attention and momentum behind them that the people, either your client or the people who have to work on it, have a kind of common idea now and a belief that this is something that can then be made real. Even if it isn't that real in its early instances, or the prototype's flawed in some kind of ways. And I think that's that idea of making things and making models or making drawings or making those instances of belief are also ways that people can share the process of producing something and find their own feet within it and their own kind of language.
In design processes, when you bring together people with so many different disciplines and backgrounds, being visual is crucial. For example, scenarios, sketches, any kind of prototypes, any kind that builds a kind of visual form to whatever is being designed, creates a sort of visual contract between people. The moment we look at something together, we reduce the risk of misunderstanding each other. We reduce the risk of going off in our own brains and thinking in different directions. So by making things tangible, visual, present here and now, people have much more alignment. People stop using their own individual expert languages, but they refer to the prototype as the common language. So the prototype becomes the embodiment of the knowledge being built that far in the team, becomes the reference point for everyone to understand each other. It's not about criticizing people, it's not about criticizing what someone said or wants to do or did, it's criticizing the prototype.
I think a really interesting secret history of new media arts and design in the period from, let's say, 2000 to 2020, okay? A history of how it really happened. It could not have happened without the creation of the free open source cross-platform toolkits like processing and open frameworks. And it's incredibly important to emphasize how much of all this amazingly sexy stuff that I see and that I make and that you guys make and that all my students make and that we see here at the I/O Festival made by the wonderful speakers here, how much that is enabled, powered, and made possible by these tools. And ultimately, it comes down to these were tools that were made for artists and designers, for artists by artists, okay, because of a failure in the marketplace. And that failure in the marketplace maybe started in 90s, arguably, where you had a company like Macromedia and then Adobe producing Director and then Flash and sort of saying, here's your sandbox, okay? Oh, you're an artist who wants to make interactive things? You need Flash, right? And Flash was good at some things, okay? But it had a very circumscribed view about what you might want to do as an artist. So, you know, if you wanted to click a button and that would trigger a video clip, great, we got you covered, right? But if you wanted to draw 100 or 1,000 lines flying around the screen, which, P.S., is a trivial thing for a graphics card to do on a computer, right? That suddenly became incredibly difficult, and the performance would be awful. You know, try using Flash circa 2002 to draw 1,000 lines flying around, or 1,000. You just couldn't. And it was a basic thing, you know. And to be able to begin to treat pixels as a kind of malleable plastic material that you could use to do art, design, dynamic typography, you know, any of that kind of stuff, and not just kind of like have fixed letter forms, fixed assets, fixed sprites, fixed pre-recorded sounds, fixed pre-recorded video clips, okay? That was the model of multimedia in the mid-90s. That was the CD-ROM era. Right? And to suddenly say, no, we want to be able to do generative work, which is synthesized on the fly in ways which are utterly malleable and plastic, and which, you know, I can't predict what it's going to look like, and I need to be able to manipulate it 10-dimensionally in, you know, all these different ways simultaneously. To be able to do that, the marketplace would not deliver that, and the patronizing attitude of Adobe and Macromedia in terms of what they thought you could achieve as an artist, what they thought you could program as an artist, and what they delivered to you as like, here's your tool for doing all your work, it wasn't there. And that is why Midas stepped in with Design by Numbers circa 1999. It is why Casey and Ben made processing as a way of kind of making it easy for artists and designers to be able to control this new medium. It is why Zach, sort of in this Promethean way, like said, like, fuck this, I'm going to take this fire from the mountain and, you know, give it out to all the people. And it's really not that hard. And so there's a few things going on there. One is, you know, to bring in a bunch of people into a community and sort of say we can all contribute to this. And if we have this, if we do this, if we make this for us, by us, it's going to have the kinds of features we want. It's going to have the kinds of affordances and kind of sensitivities we want. It's not going to look janky with aliased lines. It's going to look good. You know, it's going to be high performance. It's going to be performant. It's going to be, you know, it's going to have it's going to be very supple, and it will allow you to control graphics in ways that artists care about. But it's also going to be something that goes out to the public and our peers, and is going to be contributed to by our peers. And it's going to be something that we can all bootstrap ourselves with together. So it was actually a rejection of the marketplace, and it very much tracked the open source software movement as well, which and in so doing, it created a very sort of a virtuous feedback cycle where, you know, an artist who would come around in 2005, maybe one of my students, or, you know, or one of Zach's or whomever, would sort of look around at the commercial offerings and say, well, actually, the place where it's at is open frameworks and processing. That's where the people who are doing the experimental stuff are. That's where the leading ideas are coming from.
I think of software in general as a medium, and I think of different programming languages as different materials. The same way that, I don't know, if you're building the chair you're sitting on, which wood do you use? Do you use wood, or do you use a different material? But you're still like working within the physical structure, like that sort of medium of object making. And I think of software as its own separate medium, and different programming languages I think this. It sounds weird, but it really makes sense to think of them as different materials. Some are fluid, some are rigid, some are good for sketching, some are good for doing things that are really going to last, that are really firm. And each one requires a flexibility of thinking. You know, if you're woodworking versus working on a lathe, the way that you're working with the material is a little bit different. It's the same is really true of coding.
Like, if you're interested in thinking about how computation you can use it for your practice, it's useful to not to learn all these languages, but just to get a feel for what their flavor is, because they're almost like, to me, it just feels like, you know, Thai food or Mexican food. Like what the range of what you can do is like defined by a set of ingredients and a sort of flavor and a certain techniques and there's like a feeling. These languages have different feelings. I feel like all mediums have some way that they sort of work with you and work against you. The way if you're making like a woodcut, that you can cut with the grain of the wood or against it, and there's a kind of physical force that you feel like that. No matter, it's the interaction of the artist with the medium is like the medium is gonna push you in certain directions. You're gonna push it in certain directions. And the interesting thing is like that, the magic of what happens there. And with code, especially text-based code, there's a kind of process that I feel like it pushes you in a certain direction, you push it in a certain direction. There's certain things that it does really well, like iteration and, you know, certain algorithms that are just sort of ingrained or built into the computer that, you know, kind of push your thinking or push your design process. And A lot of it is this, back and forth. I feel like there's a meditative process. You know, I write code in C++, which means I have to compile it. It means that I don't go immediately from, you know, I write something, I press play, and it like does something, and then it shows it to me. There's probably 10 seconds there, or 15 seconds maybe. You know, it's not immediate, like a direct change in the code, you see a direct change in the visual. It's like, but it's not slow, but there's something there. And I feel like that process, there's something that happens to me where I am in that space. Oftentimes I'm almost like daydreaming about the change that I've made and what it will look like. And then it shows it to me, and it's either like close to what I expect or not. And that process feels really beautiful. Like that, there's a rhythm to working with this medium that I'm like, will it do what I think? And then it will. Or will it do what I think? And then it doesn't. And that, I think that, to me, it's not necessarily the text, but it's a kind of rhythm of like change, see something, change, see something, that I find a lot of magic of. For me, those moments of like, I think it's going to look like X and it looks like Y, and then I'm excited about that, and then I want to push that further. You know, that the discrepancy between what it actually looks like and what I think it will look like. That those vectors, like those are interesting to explore.
As a graphic designer, I wanted to incorporate sound, and I wanted to incorporate video into the work, these time-based media. And for me, the CD-ROM kind of era in the 90s was the opening for that. And then you were able to sort of combine all these things together. And then the web happened, and we were kind of back to static text again. And then Flash became a really good animation program, and then became a program for interactivity. And I think we kind of like expand and contract a little bit.
I don't like miss making projects in Flash and ActionScript, but there was something really nice about having this tool, which was kind of like halfway between, something very physical where you're like drawing things or dragging things in, kind of moving things around on the timeline, then like to turning those things into elements that you could programmatically control. And it had, there was a very novel thing about it, like that you could interact with what you were doing at many different levels. I see a lot of designers struggle with text-based programming just because you can't touch something. It's not, not as physical in a way.
And so another way to make things with software is to go a level below that and to actually write the code yourself. And it's more tedious, it takes more time, but it gives you a lot more control over the medium itself. And so with processing, the idea was to build a system so that people could write their own code to do things that were different from what those other programs did, or to do something different than what those programs really did. Something more specific. Like if you're following an idea and you're really pursuing something, and then that program won't allow you to do that thing. If you can write a program, you can explore it further. It gets around the boundaries, and each of those programs has a set of pretty firm boundaries. What if you're Charles and Ray Eames and you're figuring out how to mold plywood for the very first time, and you're doing prototype after prototype after prototype? There's no engineer around who can tell you how to do that, because you're really kind of doing it in a really specific way for the first time. And I think that's a lot of like the spirit of working with code directly in processing. It's just, you're somewhere where no one's really ever been. Let's figure out how to make a jig for doing this like really specific thing, and then you make the tool. And then what do you do with that tool? Do you release that tool for everybody else to have access to? Do you open source that? Do you keep it internal to your organization? You keep it proprietary? And a lot of processing originally was code that had been written and was being used internally, but what we thought was more interesting was to release that all so other people can work with it, to like grow the field as a whole rather than to hoard like the information and the knowledge. Basically to take what was happening at that time and had been happening for 15 years at MIT and to really get that out to an international community so that the field as a whole can really progress and change.
What really, I think, marks Open Frameworks as a fantastic experimental tool is literally the open part of it. There's a website called ofxaddons.com where hundreds of people have contributed you know, little bits of code that do very powerful things to extend the functionality of open frameworks in incredibly interesting ways, whether it's with computer vision or machine learning or in artificial intelligence or various kinds of like fast algorithms or even just various kinds of file input and output and, you know, networking and all these different, you know, different kinds of device hardware and all kinds of things. So whether, you know, it reminds me very much of that scene from the first Matrix movie where Keanu Reeves is like, you know, talking to Trinity, and he's like, we need guns, lots of guns. And it's like the Matrix stockroom, and all these like shelves go flying by of like, just like guns everywhere. And it's like that to me is the experience of being at ofxaddons.com, where there's just like all this kind of candy store of incredibly powerful tools for doing stuff that can plug into what this kind of basic open framework for making things. And that means it's wonderful for experimentation.
I kind of turned the corner and said, okay, the web was the transformative digital technology of the 90s. Hardware is going to be the transformative and lowering the barrier to entry and exploding these computer-like devices into everything is going to be the transformative technology of the near future. There's kind of two visions of ubiquitous computing. There was the original Mark Weiser version of it from the late 80s, early 90s, which is that computing would fragment into tiny connected computers everywhere, but you wouldn't see them. Like he uses this analogy of kind of a walk in the woods, you know, like the woods back here, and you're walking through the woods, and there's computers around everywhere around you, but you don't know where they are and you don't care. And you walk into a room and there's computers everywhere in the room, but you don't really see them as computers, and you don't see it. So that was one vision, and that's a very California utopian vision that I don't think I ever really agreed with. I always thought that you know, I was an interface designer. I always thought that like there's an interface. They're like, you need to be able to know that you're interacting with a thing. But I did believe that the things were going to be all the things. That door handle was going to have a computer that I would somehow interact with. That there was going to be this mass fragmentation into all of these things. And it wasn't clear exactly how that was going to work, and it wasn't clear exactly why it was going to be there. But I was pretty sure that that was going to happen.
Physical computing stuff actually starts with him in, what, 91, 92, right?
Which oddly came out of that same project that Tom was referencing, which was a project we both worked on, Yorb. It was that public access, real-time rendered virtual reality world that people controlled with their phones. And being able to control them with their phones or with voice control was not something that computers at the time could do. And so we had to build our own gear to do that. While we're building it, we're like, oh my God, that could be, you know, you could
do stuff.
You could really turn things on in the world, and you could reach a body. So that just like turned on a lot of people. And in particular, I'd say fine artists, you know, because in some ways it allowed you to create an interactive object.
Wouldn't it be just so awesome if you could just take any kind of sensor, like a temperature sensor or a flex sensor or a motion sensor, and connect it to a website? Wouldn't that just be so awesome? Because then the web could be made up of real stuff, not like written stuff. And it would be alive. Wouldn't that be amazing? And Brian thought about it and then said, I know how to do that. Let's do that. And so we started taking parts out of old MIDI keyboards that were analog digital converters. So you could basically put a sensor, like a force sensor, onto a device and have it turn it into numbers, variable numbers, into an input. And so we could say the size of this square on the screen is equal to the temperature outside on the windowsill or something. And we still didn't even know what we were going to do with that. And it kind of didn't even matter. Just the playing with that endless amount of potential was incredibly exciting in itself, incredibly rewarding. And so we kept making toolkits. We made some of our own hardware boards. We made software for other people's hardware boards. We adapted Flash which was the most popular visual programming environment that designers were using at the time to work on the web. You could incorporate sound very easily and video very easily with sensors. And then when things like the iPhone came along, we immediately started adapting them to take all of the sensors that were inside of them and their potential for having great screens, being able to play video, being battery rechargeable, being relatively weatherproof and rugged as platforms for prototyping. So rather than making apps for the phone, we were having our students cut open stuffed animals and stick the phone inside, but have the phone be this incredibly powerful small computer that could also make all the sounds, and eventually some of our later toolkits actually control robotic actuators.
I want to expand the space of people who can work with digital hardware. I wanted to, and I wasn't thinking about, if you look at the maker movement is essentially focused on 14-year-old boy children of engineers. And I was like, that is not the audience that I think actually needs all that stuff. I was actually thinking of expanding it to the people that I really wanted to use these tools, the designers.
When I came as a first-year student in Ivrea, wiring existed, and that was at that time was the thesis project of a student from 2 years before, Hernando Barragan. It was his thesis project, and we had some of these boards that were from a production that he made, and Massimo made some for our class. And that was our first exposure at that time to physical computing. With Massimo guiding us through the electronics, it was, we started developing our own tools. And I think that's where, of our class, Dave Mellis, who runs Arduino now, had the deepest technical knowledge of us in our class, and he just really dove in and really understood microcontrollers. And I think him spearheading Arduino and then us all building libraries and building toolkits on top of it really made our class kind of cohesive through tool building. That was the goal of it, was to make the tools accessible to people from a creative background without much programming knowledge. But I think at the same time, none of us building the tools were really embedded systems engineers, so we were kind of building them as a naive person would build them. And I think that helped make them understandable as well. Having kind of a knowledge of computing, but not coming from computer engineering or a microcontroller background. And then also following some of the design patterns of wiring, as kind of an initial impetus of what the stylistic aspects of the language are, in human terms. I think that all that kind of came together. A design process should feel kind of like a smooth kind of dialogue. And the faster you build things and you try things, it's like an efficient conversation. And I think that realization was one that I think we came through with the tool set of the value of speed in building things.
Even before I actually went geocaching, the first time I went to some electronics store and bought a GPS unit and brought it outside and had to wait for it to calibrate with the satellites and could see, okay, it's got one satellite. It used to take like 40 seconds, right, to calibrate. And to really be like, oh, this is talking with 4 satellites, or 6 sometimes. And now it knows exactly where I am. That was way more interesting and important to me than having something in my pocket that allowed me to talk to somebody wherever they were. Like, it was just, that to me was just magic. And I would say basically starting in '99 was where I started thinking about this is going to change everything. It's going to change shipping. It's going to change driving. It's going to change war. It's going to change cooking. It's going to change everything. But what I was interested in is how it would change how we play.
I think people make a big deal out of like the value of the utility, the importance of kind of usable software. And of course, if you have to deliver insulin to someone, it'd be really great if it wasn't like Snapchat, right? So within the limitations of my own universe as an entertainment designer, or as a designer working in the entertainment industry, or at least media, it made a lot more sense to start looking at these things more holistically. And for me, that sort of meant that whatever the sort of critical design thinkers were saying, and whatever the human-centered design thinkers were saying, somehow didn't encompass the fact that with something like Snapchat, you can have an extraordinarily successful product that hundreds of millions of people are using, with a huge degree of satisfaction, and not finding the fact that there are parts of the way the system works that are opaque, a particular problem. For me, like the character of that software, the whole point of it, doesn't matter whether you can use it or not. So the problem with like, you know, the sort of generation of like super usability or human-centered idea that Snapchat's got a bad UI, just grossly misunderstood the current state of media, which is that it's play. And in that sense, it's kind of a video game. But then once you look at it like that, and then you look back at iOS and all the other apps, it's not impossible to take a leap that it's all kind of a video game. So I find that game designers have developed a very acute discipline for taking the users or players incredibly seriously in the first moments of interaction. And of course, how they keep you interacting over time is also very significant. But if you look at the games that succeed and look at the decisions, the absolute forensic micromanagement of how the interface works, how the graphics work in order to continue to make sure you always understand what's going on. Nothing is ever opaque. It's like nothing you'll ever see in software. Certainly nothing that anyone like Google have ever done. You know, if you look at the state of fucking calendar, you know. So it's just, you know, for me, that's something that interaction designers can learn from. It feels very distinct to me, the era of software that I had on Macintosh computers in early 2000s and the kind of software that I have on phones now, which is, you know, very, very different sort of culture of how my behavior tends in my use of them. So I think there's something a little bit sinister about the idea that there's just this kind of huge herds, tribes of unconnected people all poking their meaty, wet fingers away on their kind of capacitive screens in order to trigger minor endorphin responses or social reward or whatever it is that the thing is, you know, because it's like a little Candy Crush pop or because someone hit like or, you know, whatever the thing is.
The foundation here really focused on curiosity, helping people to understand certain design principles, let's say in two-dimensional, three-dimensional aspects, later on also animation, connecting these to core knowledge in the liberal arts, to widening the discourse about it, to understand why we are doing these things, to understand how meaning is being generated. But what was really important for me is that these different elements actually showed me different starting points for innovation. It could be in the way of how we interact with some product. It could be in the material quality. It could be in the aspects of natural laws and patterns emerged over millennia. To the way of how we interpret them. So meaning that inspiration, innovation came from a diversity of sources and that you needed to research, understand these better and build connection, new synergies between these different learnings. I think that's one of these foundational principles of the initial first year at most of these foundational programs. Now, what I learned later on, that computational techniques should be also part of these kind of skills. It's not just enough that you know to deal with materials in our surrounding, from wood to metal to whatever, plastics, but now that you also need to deal with the immaterial materials of our surroundings, the I&Os which inform the way of how we shape software solutions and others. And so as 2D and 3D courses took apart the way of how we deal with it and not just only teaching you how to operate a machine, the core idea of rethinking the interaction with software was you shouldn't just use pre-programmed software to design something, but you need to learn how to use or build software in itself. So these aspects probably have changed our understanding now of foundational years, bringing in ideas about data, information as core aspects which we would need to deal with in any kind of foundational training program for designers.
I think what's going on with foundation studies is that time is so, I think about things systemically. Time has become so critical and so important. And I think that's another layer of things, but interactivity is even something that's different from time. It's about that response, that feedback. And I think that's a whole other thing that should be included in a foundation study. And I think writing code in some form, whether it's a visual programming language or it's sort of selecting options from a menu for doing interaction experiments, is that idea of call and response between yourself and another person, or yourself and an interface, or yourself and an object. I think it belongs in foundation studies. I think there was a time before these like, tools that we've been using and growing up with, or become like moving through our profession with, where if you really wanted to do something relatively simple, like is there a person in front of this camera or not a person in front of this camera, then that really would require working with a graduate student in CS or going over and taking, you know, a few semesters of classes at Brown before you could come back to RISD. And I think what happened through that era was that a few people were able to do that, but for most people, you would go over there for a class or two and then come back to the art school. And it's not because people lacked the intelligence or the motivation. It was the classes were being taught in a way where it was like a right angle to the students' interests. And so I think the big idea of processing was, let's teach the same ways of thinking, the same conceptual tools that you learn in a computer science class, but let's do that all within the context of making images, of making animation, working with photography and video, basically the things that the students are motivated about. And we also structure things in a different order, which took a long time to kind of, it's always iterating, but a long time to get started with. That computer science has been taught more or less in a similar way for decades. How do we teach things with different emphasis, in a different progression that makes it possible for this whole other group of people to make use of software for their own professional goals?
For artists, any kind of material, any kind of new language is a moment of kind of joy and curiosity. And so all of those new tools and expansive ways of thinking and making are being brought into the first year. We look at coding as a tool just like charcoal is a tool. And the students do incredible things. Our students are not the kind of students that just want to use software. They want to reinvent everything or invent everything from their own personal perspective and their own curiosity.
I think that for me, history is essential because we keep seeing the same work made over and over again. And I think it's been 50 years since the first people started writing code to make images. There's a long tradition in history here. And I think you learn from history so that you can make leaps rather than continue to do the same thing over and over again. And when you talk about software as a way of making things, of course, it's, again, this is going back to this not just technical. It's the ideas that go back decades and decades, centuries, multiple centuries even. And so how do we think about this as a continuum where it's a history of ideas and not just a history of technique? But I think also it's important for the students to see this work so they can move beyond it, make new contributions, rather than rehashing things.
I think an important message as an educator is always to say that the world is hungry for ideas. There's huge gaps. We need better tools. We need better institutions. We need better companies, better projects. Like that's a lesson that's hard to see as a student. It's hard to see as a beginner, but that's an important lesson generally to push. But I also think connecting students with the past and trying to help explain to them that they have an ability and maybe even an obligation to recreate the past in their own voice, that they can engage with the past, that there's this really beautiful sort of rich work that people have done. These people came before us, they have lessons to tell us, and we can listen to them and we can take their voices forward. And it just feels like every generation gets a chance to do that. And especially in this field, there's such a, people always ask like, what's the future gonna be like? Everything's so sort of science fiction and future oriented that I feel like I really wanna push students to look back. And I got this from people like Golan Levin, who I studied with, who was always, pushing us to look at Oscar Fischinger movies and, Norman McLaren, Mary Ellen Butte, and all of this early abstract animation. And just to sort of say, like, go back, let's look back in time. Let's say, what were people doing in the 20s, 30s, 40s in cinema? What is this experimental work that people were doing, and can we take that energy and bring it forward?
Now we're moving on in terms of technology with artificial intelligence, machine learning. Voice might become the primary interface. So I think that's a really interesting question, whether the interfaces that we have designed using classic visual and interaction design things in the past will become even less important in that relationship.
You don't teach them what to think, you teach them how to think. And then every new thing they come along with, they're able to apply that. And you have to be comfortable that you're endangering your students with being called a fraud or illegitimate because they are not proper industrial designers, because they didn't take that full array of classes. They are not computer scientists because they don't know all these basic algorithms. Yeah. But I can feel okay about that because they know, we worked backwards from that project-based pedagogy where they came to their project and they learned the specific algorithms they needed for that. The act of being resourceful in learning those algorithms is the thing that's going to serve them when they go and face another thing. But most importantly, when that other thing doesn't exist yet.
Yeah.
Like in engineering school, they'll give you the algorithms for all the things that have come in the past. And that's a great approach and it's going to help you in the future. But we're really giving them that notion of like, hey, you're not going to know what's going to happen next and you're going to have to figure it out.